Next example. So now we have a population of 100 ants, doubles every 5 years. Every 5 years. So graph the population growth. All right, so what's the initial amount here? Initial amount, we have 100. Okay, 100 ants in the beginning. So year 0, we start with 100 ants. And after 5 years, it's double. So it doubles, so times by 2. So what is it? It's going to be 200. And another 5 years, it's going to be doubles. So it's going to be double up, so it's going to be 400. And times by 2 for next 5 years, it is 800. And it is another times by 2, it is 1,600. All right, so let's plot it. This is going to be 0, and I'm going to go up by 5 and 10 and 15 and 20. Let me stop. Okay, it's 25. And I'm going to go up by 100. So it's 100, 200. You know what? I'm going to go up by 200 because we have a 1600 here. So I'm going to go up by 200, 600, and this is going to be 1,000, and this is going to be 2,000, and we have 1,200, 4, 16, and 18. All right, so now when times 0, this is a time. You have to label x-axis and y-axis, and this is number of ants. All right, so when x is 0, the number of ants is 100, right? So 100, point is here. When x is 5, times 5 in 5 year, in year 5, the number of ants is 200. In year 10, the number of ants is 400. It's increasing. Year 15, it's 800. 800. Oh, you see it's increasing a little bit faster when it's 20, year 20, and it's 1,600. So if you connect this, it will look like this. Okay, let me choose different color. So it is also exponential. It's increasing faster, right? From here. Okay, so you see that this is also exponential function. All right, so let's try. So please remember this and remember how to graph, how to label them, and how to put appropriate numbers on the scale. All right, now we're going to talk about exponential decay. Decay is things aren't decreasing. Things are decreasing. All right, so as you see on the graph, you see the numbers are decreasing, right? Okay, so exponential decay. Let's talk about the definition. Can be modeled by the function. Also, we're still talking about exponential function. The base b is the decay factor. So the number that you keep multiplying, that's the decay factor, which equals 1 minus. Oh, you know what? Let's not talk about this part because just remember, like the number that you keep multiplying, that's the decay factor. All right, the base is the decay factor, so the number that you keep multiplying. And A is initial amount. All right, so let's look at the example and try to understand this concept. All right, so what is our initial amount? Initial amount, 20 ants. And what's the growth factor? Oh, here, it's not growth factor. It should be decay factor. Because you see here, things are decreasing. So let's finish the table first. So year 0, it was 20 yens. And after the first year, no, every 5 year, no, every year. Sorry for all the typos. Okay, every year. So it halves every year. All right, so after next year, after 1 year, it's going to be 10 because it halves. Okay, so half 20 is 10. So you multiply 1/2, right? And 10 to how many ends are you going to have next year? It's going to be half of 5, half of 10, half 10. So that's 5, right? So you multiply by 1/2. And I know it doesn't make any sense because we don't count ends by like 1.5, 2.5, but let's just keep following the pattern. So it's going to be 2.5, right? So I may stop here because it doesn't make any sense. All right, so now let's graph this. 0, 1, 2, and 3, and 4. I may stop. And I'm going to go up by, okay, this is going to be my 10, and this is going to be 20. And this is number of ends. All right, when x is equal to 0, year 0, number of ends was 20. In year 1, number of ends, 10. You see things are decreasing, right? What about year 2? It's 5, so it's in the middle. So it's decreasing, but slowly decreasing, slower than the first year. And year 3, it's 2.5. 2.5 is, this is 2, 4, 6, 8. This is 2 and 4. So it should be between here. So you see that things are decreasing, right? So if you have this kind of questions, you always start looking at the initial amount. And what's the decay factor? What number you keep multiplying here? You keep multiplying by 1/2, right? So 1/2. So if you want to put them in the equation, it's going to be y is equal to initial amount, and you have to put the decay or growth factor, which is 1/2, to the x power. And that's it. Before we start, so we're talking about the rabbits, and it halves every 10 years. So I ask you to change it to the number of years. All right, and we need to find the initial amount. So initial amount, year 0, it's 1,000. So initial amount is 1,000 rabbits. And it also decay factor because things are decreasing. When things are decreasing, it's decay factor. When things are increasing, that's growth factor. All right, so decay factor, it halves. So next year, how many? Next 10 years. In 10 years, it's going to be half of 1,000, right? So you multiply by 1/2, then you will get 500. 500, another 1/2, so you get 250. And in 30 years, you're going to get 125 rabbits because you have to keep multiply by 1/2. And you're going to have 62.5. I know theoretically it's impossible, but let's just find the rule. All right. So this is time, and this is number of rabbit. All right, so now I'm going to go up by 10, 20, 30, and 40, and 50. We don't have 50 though. All right, 0 is here. And I'm going to go up by, okay, this is my 1,000. And this is 100. So I'm going to go up by 100. Let me plot them. So when x is 0, y is 1,000. When x is 10, y is 100, 500. And when x is 20, it's 250. And when x is 30, it's 125. And when x is 40, it's 62.5. So the equation is going to be